In this video, we will be deriving the product rule of differentiation. So the derivation of product rule. So when we are talking about a product rule, we are talking about a product of two functions of the same variable. So what we are talking about? We are talking about, say, a function ux and vx. So these are two functions of the same variable x. What we need to find out is d by dx of the product uv. So now, as in any differentiation by first principle, what do we require? We require the change in function upon the change in the variable, right? And that's my difference quotient, for which I look at a limit as change tends to 0. Now, so first of all, I need to come down to the difference quotient. So for that, what do I need? I need the change in the product function. So change in uv. What will be change in uv? Now what is happening is that x is changing, right? So the change in uv essentially will be u of x plus delta x into v of x plus delta x, right? Minus the original function, which is the product of ux and vx. Okay, so what is happening essentially here is that your x is changing from x to x plus delta x. Okay, hence the product function will change into this. Okay, so this is a very crucial thing to keep in mind while working out with the derivation. So now what we can do is we can just collect some terms out here. What we can do is we can just collect certain terms. We can collect u with u. So ux plus delta x minus u. If I'm doing that, so what am I doing? I will have to introduce certain terms in order to do this. So let me just recollect these terms in a useful manner. So what we can do is we can simply add and subtract ux into vx plus delta x. Okay. So let's just do that. ux plus delta x minus ux whole into vx plus delta x. So now this was my first term in any case. Minus ux into vx plus delta x is a new introduced term because I wanted to utilize this. Plus, if I have subtracted ux into vx plus delta x, I will have to add it also, right? So that the term doesn't change. So I just added up as well. So ux into vx plus delta x is added out here. And this last term remains as it is, ux into vx. Okay. So just see that. So x plus delta x minus ux collected together, whole into v x plus delta x plus ux into v x plus delta x minus the last term as it is. So these are my newly introduced term. So again, what I can do out here is I can again collect certain terms because ux comes in common. Just see, ux is common in both the terms. So what we can do is ux comes common, ux comes outside, and inside bracket I have vx plus delta x minus vx. So you have a bigger bracket here and a bigger bracket here. These are important brackets, mind you. Now I will take the ratio as delta x. Okay. So the ratio of change in uv and change in x will look like this. Whole upon delta x. What I can do is I can just simply put delta x beneath the bigger brackets. Okay, beneath the bigger brackets. So it comes here as well as something missing here. It comes here. Delta x. So that's my difference quotient. That's the difference quotient that we are talking about. This is the difference quotient. Okay. Now we need to take the limit. the limit as delta x tends to 0. So when I take the limit as delta x tends to 0, what are these recollected terms in the bigger brackets? These terms, ux plus delta x minus ux upon delta x. What does it actually tells us? It tells us it's the first principal rule for u dash x, right? So d by dx of ux. It's nothing else but d by dx of ux. Similarly, this bigger bracket upon delta x is nothing but the change in the function vx to change in the variable x. So d by dx of vx. So this is v dash x. So hence, what do I mean to say from the difference quotient limit? After taking the limit, that I know that this first part of the difference quotient is nothing but d by dx ux into vx. And the second part of the difference quotient is nothing but ux into d by dx vx. And hence I get my product rule as uv whole dash equals to u dash v plus v dash u. So this is we have proved using first principles.